So today we just have some short notes on looking at the concepts behind racing, but more importantly, safety in terms of driving. So the first idea is speeding is usually associated with deaths and accidents and things like that. But ironically, it's not going fast that kills somebody. It's what? Can you go like 200 miles in a car? You can, no biggie. It's the stopping part you got to be careful of. Exactly, it's the stopping. A large acceleration requires a large force. Whose law is that? Newton's second law, right? F equals ma. So if you think about it, if you have a sudden large deceleration, it's going to take a large negative force on your body. Hopefully you have at least a seatbelt on, or if you do crash, the car crumples, you got airbags, things like that, and you're stopped okay. But the worst case is you don't put on your seatbelt and you're in big trouble, okay? So what happens is, if you're going at 50 miles an hour, what does your body naturally want to do? Naturally wants to what? Keep moving at 50 miles an hour. So which law is that one? Sorry, it's Newton's first law, the law of, starts with an I, remember? Which ninja? Yeah, the inertia ninja, okay? So inertia, I-N-E-R-T-I-A, or lack of force, allows you to instead fly through the car and hit something dead on, which is not cool, okay? So in the end, racers, they're just not crazy people, okay? They actually have to think. And normally, when you're driving, okay, what's the big thing they teach in driver's ed? It's not the fact that it's speeding that kills you, it's the stopping. But when you speed, right, it makes it harder to stop efficiently. So in the end, I know this might feel like a little like driver's ed, like let's freak out all the students so they don't drive bad and kill each other. But really, it's something we take for granted, okay? If you think about it, if a car's going at 20, 30 miles an hour doing a crash test, it's that natural inertia of the dummy there and the body that makes it so dangerous there, right? So that's why cars are designed, if you ever see a bad car wreck on the highway there, it always looks like the front or back or the side just totally just gets demolished there, right? And is that an accident? Or do you think that's on purpose for the car to crumple like that? Which one? It's on purpose, exactly, okay? These are called crumple zones. It's designed on purpose so that the kinetic energy of the car, which is huge, right? You got a huge amount of mass moving at high velocity, it's velocity squared, can be dissipated as work energy, also called deformation energy. So rather than the occupants taking all the damage, we let the car do that, okay? Tons of engineering physics for safety there. So here's a question for you. Why don't we make cars like bumper cars? Put on big old rubber bumpers, and then every time you have an accident, have the cars bounce. Wouldn't that help protect the cars? What's the problem there? So the car would survive, right? Intact, but the problem is, passengers, okay? You would bear the brunt of the G-forces involved, the large accelerations, and then also momentum, which you're going to look at next, okay? It's too big of a momentum change if you think about it. So that's why cars are designed on purpose to crumple, which is bad, but usually it's okay as long as you're not hurt, okay?